Okay, welcome back to the Book 2 revision exercise, chapter 6. So we are starting the long questions. So there is a horizontal force acting on a trolley, and the mass of that is 2 kg on the rough surface, and it travels for 2 meters. And if the trolley travels at constant velocity, so you need to be aware of these keywords, rough, constant velocity, okay, throughout the whole journey. So find the work done by the applied force. So work done is really easy because it's always equal to the force you provide along the distance travel. So it should be equal to this 10 Newton. You provide 10 Newton forces, right? And it travels for only 2 meters. So you may just use 10 times 2, which is equal to 20. Remember, work is an energy, so the unit is joule. Okay, then secondly, you need to look for the gain in KE. The gain in KE. So I myself would just give the answer directly without doing any calculation. The reason is, it's moving at constant velocity, right? That means it's not getting faster or slower. It has the same KE throughout the whole journey. So that means the gain in KE is simply equal to 0. There's no gain in KE. Okay, thirdly, find the work done, find the friction. The friction is simply, since it's constant velocity, right? So just imagine if there's a trolley having a force 10 Newton pushing it forward. The friction would be balancing this force directly, because we know that for constant velocity, net force is equal to F minus small f, which is your ma. And now this acceleration is 0. So that means friction is simply equal to the force you apply to it, which is also 10 Newton. Very simple question for this one. It's just like a concept checking. Okay, let's continue to the second one. A ball 2 kg falls freely from rest and at a height 1.2 meter and come to the rest after penetrating through 5 cm sand. It's a difficult question for this one. So you need to really be careful when you are listening to that. So there's an object falling down. It dropped by 1.2 meter, and then it come to the sand. This is sand. So in the sand, it travel for another 5 cm, which is 0.05 meter. So be careful for this value. And notice that in this region, there will be resistive force. Okay, resisting force, sorry. So when you try to find out what is happening into the sand, you need to consider the work done against the resistive force. Okay, so I just call this point x, this point x, y, and this is z. When we are doing the energy questions, we have to be identifying the starting point and the finishing point. So for part A, we look for the velocity when it arriving the sand, when it hit the sand. That means we should consider the motion between x and y. So for part A specifically, I would consider from x to y, x to y. Since there is no other force acting on it except gravitational force, that means the loss in PE should be equal to the gain in KE. So I may write down directly loss in PE equal to gain in KE. So that means mgh is equal to half mv squared. So we may cancel this m, and 2gh is equal to v squared, which is v equal to square root 2gh. Remember in the previous questions, I showed you this. I told you, in fact, you can use directly if you are good in memory. I mean, you're good in memorizing things, you may just do this directly. So v is equal to square root 2 times 9.81 times 1.2. This is the height we refer to. It dropped by 1.2 meters. So the V should be equal to 4.85 meter per second. So which is the part A. Okay, so for part B, we find the received average resisting force exerted by the sand on the ball. We may use the motion between Y to Z. Now from Y to Z, notice that there is a loss in PE, but also originally it has a KE here. But at the end, the KE would become 0. So that means throughout this motion, there would be both PE and KE loss. And those loss of energy are from the work done against friction. So we may write down work done against resisting force should be equal to loss in PE plus loss in KE. Okay, so we may just put everything into the equation. So the friction times the distance traveled, 0.05, which is equal to the loss in PE. Similarly, the loss in PE should be mgh. This h is only referring from Y to Z, so that means you should put also 0.05 here. And then plus the loss in KE should be equal to half m. This is the velocity. We call it U equal to 4.85 and V equal to 0 for the motion from Y to Z. So that means you should put 4.85 square. So that is the information you need to be able to read. Now try to read this before you go on to the next part, okay? So this friction times 0.05 should be equal to, we put the value back here, 2 times 9.81 times 0.05 plus half. The mass is 2 times 4.85 square. Okay. So I have this one. I calculated that previously. So you may try this by yourself, and the friction would be equal to 24.525 divided by 0.05, which is 490.5 Newton. Okay, that's right. So that is the part B. Okay. So finally, we want to do also the part C, right? Part C. If we want to find the deceleration of the ball in the sand, so in fact, you just need to look for the information about this motion. If U is equal to 4.85, which is the starting velocity, initial velocity at this point, and finally it comes to a final velocity 0, and the displacement is traveled by 0.05. Okay, so we look for A. So we got UVSA, that is the equation for us. V squared equal to U squared plus 2AS. So that 0 is equal to 4.85 square plus 2 times A times 0.05. All right? And you may just do the calculation by like negative 4.85 square equal to this 2 times 0.05 is 0.1 A. So A is equal to negative 4.85 square. Oh, sorry. Divide by 0.1. Okay, by your calculator, you got the answer. Should be 235 Newton. Okay, you may check the calculation on your own. So this is the answer for question 2. Okay, so let's continue to the question 3. All right, so now we have a block sliding down through a smooth plane, and then there's a 5 meter rough surface to slow down the object until it comes to the rest. And first we need to find the velocity of the block. Now notice that the plane here is smooth, so that means there's no energy loss. So we consider motion from X to Y. In fact, it don't involve any work, right? So that means loss in PE should be equal to the gain in KE. Okay, so mgh is equal to half mv squared. So I did that many times already. I told you we may use this directly, right? Square root 2gh, so that means it's square root 2 times 9.81 times the height is 1. So what we have is 4.43 meter per second. This is the part 1. Okay, it's pretty easy. If you did that many times, you may find that, oh, it's always the same, right? So later on, we need to consider the friction force on the rough surface. So we may consider from Y to Z. So in this process, there is only change in the velocity. That means there's a loss in KE, but there's no change in PE because it's on the same level, right? So what we can write is like the loss, loss in KE. The police is coming, huh? Which is equal to the work done against friction. Okay, so there's a loss in KE, and all these KE are actually taken away by the rough surface, the friction. So now we need to look for the value of friction, right? So we may use half mu squared. Why I'm using u? Because I'm talking about the initial velocity at this point. Okay, and the work done is friction times distance traveled. It should be 5. So I try to put all the numbers there. Half times mass is 2, 4.43 squared, which is equal to F times 5. So friction is equal to, like, cancel these two first now. 4.43 squared divided by 5. So which is equal to 3.92. Okay. So this is how we handle that. The thing about that, what is the energy change in all questions? There's a loss in KE, no change in PE. So that the only work done is from the friction. The friction is taken away, the KE, by work done against friction. So that's how we handle this question. Okay, next. Like if originally I have the inclination theta, but it has a height 1 meter, right? What if I change the angle? I change the angle to a larger slope, okay, larger slope, but we keep the same height. What will happen to it? In fact, the speed at this point would be still the same, right? The speed at y is constant because we keep the same height. The speed only depending on the height we release. It doesn't really relate to the angle of the slope. So that means we should have the same stopping distance. Right? So the only reason is loss in KE is equal to the friction times displacement. So now the loss in KE are the same. And the friction is still the same, right? So if these two terms are the same, the distance traveled on the frictional plane, the plane with friction, should also be the same. So that is the answer for the third part. Okay, finally we come to the last question. Okay, there is a electric train leave a car of mass this and up to a height 7 meter in 10 seconds. Uniform speed. When you see this uniform speed, that means the change in KE is 0. That means you should only consider potential energy change in this case. There's no change in KE. So when we look for the power exerted by the crane, so power should be equal to the work divided by time, right? And now all the work would go to the gain in PE. So we do this directly. Gain in PE divided by time. So which is equal to mgh divided by time. According to the question, we got the mass 1500 and 9.81 for the G, and then the H is 7 meter, mgh, divided by time is 10 seconds. So what we have is 10300.5 watts. Okay, that is the part A. Okay, part B. Now this is the actual power delivered. That is delivered to the car, right? But what would be the power consumed by the motor? So we may write in this way: power consumption. Wait, that means the power actually consumed by the motor. There would be a 90% efficiency. That means we need to times 0.9. Only 90% of that would become effective, right? And which is equal to 10300.5 watts. So this is the useful power. This is the power you put. Only 90% is useful. So if you look for the power consumption, wrong spelling here. Consumption should be equal to 10300.5 divided by 0.9. So that is 11445 watts. Okay, so that is the answer for the question 4. So please spend time on revising these questions, and especially if you find any difficulty, you may just pause and repeat to understand everything about the questions. They are really typical questions. And if you got any questions, you may just let me know through WhatsApp or any ways, any means you can reach me, right? So spend more time on the revision, and the examination would be taking place in January. So even though we may not be able to come back for the exam, I would do that online with open book. Yeah, so please make sure that you got good preparation. So thank you. See you. Bye-bye.